Okay, so now what we're going to do, I'm going to change things up. We're still going to find slope, right? Again, slope is the change in y over the change in x, right? Or the vertical change I go through divided by the horizontal change that we go through, right? So no matter how you cut it. But what's different is rather than giving you a picture, I've given you a table of data. And so to find it, we actually have three things we can do, all right? But probably the first one that becomes pretty obvious is why don't we use our slope formula? All right, so let's use our slope formula, which means I need to pick a couple of points that I like to use in there. And if you've been following along, it doesn't really matter which 2 points I'll use. So how about I use this as my x1 and my y1, and I'll go ahead and use that as my x2 and my y2. If you don't like those 2 points, use any of the other 3, because the slope is the same no matter how you do it. So I'm going to choose those 2 points. So plugging my information in, my y2 is 2, my y1 is -4, right? My x2 is 2, and my x1 is -2, right? So there's all my plugging in my information. 2 take away -4 is the same thing as saying 2 plus 4. 2 take away -2 is the same thing as saying is 2 plus 2. And so we end up with 6 over 4, which reduces down to 3/2. So this basically means that if we were to see this on a graph, right, for every movement that I move 2 units this way, there's a movement of 3 units that way. And of course, that'd be another way to do this. So go ahead and get a grid, and you can start plotting your points, right? -1, 3, 4, 1, 2, 3, 4, 5, 6, 7. You can just start plotting those points, -2, -4, and you can start seeing that motion that way. So you can either visually count it or use the slope formula. Of course, if you're really astute, you can kind of almost see that in the graph itself. It's kind of like a visual count. You can see that to go from -4 to -2, I'm adding 2, adding 2, adding 2, adding 2. And meanwhile, while we're adding 2 in the x direction, we're adding 3, adding 3, adding 3, adding 3 in the y direction. So you can almost kind of see the change in x and the change in y in the table itself. So maybe that's a third way to find it when I have a table, right? So you either use the formula, you graph it and do the visual count, or you just see it in the table. All right, so that choice is yours. Just make sure you're explaining yourself. So number 2, again, we have a visualization of a table. So let me go ahead and just use our slope formula just to keep practicing that and using that. Very important formula. So how about I use be a little different. I'll use this as my x1 and my y1. And how about I use that data point way at the end as my x2 and my y2. So plugging into my formula, right, my y2 is -4, my y1 is +4, my x2 is 12, and my x1 is -8. And so upstairs, -4 take away -4, -4 minus 4 is -8. 12 take away -8 is 12 plus 8, and we get -8 over 20. And I think if 4 goes into there twice, and there 5 times. So I am getting a slope of -2/5, which means if we were to graph this table, right, so if we were to get a grid out and actually graph this data, so -8 and 4, and start moving, I would notice that I would move over 5 units and then drop down 2 to get to the next point. All right, so I'll let you guys visually count, and there's that. But you can also, again, see that in the data, right? Notice that in the data, all the x's are going up by 5, right? So there's a +5 in the x direction. And in the y direction, we're going down 2, down 2, down 2, down 2. So there's a -2. So my slope, right, again, change in y over change in x is -2/5. So you can see it in the table. You can use the formula like I've been doing, or you can just use the visualization. That's the only one I'm not showing. I'm not visually graphing it, but you can do that. So the next one, how about I approach it this way? If you just look at the data itself, we're going from -5 to -2, so that's a jump of 3. -2 to 1 is another jump of 3. 1 to 4 is another jump of 3. And 4 to 7 is another jump of 3. So it looks like the delta x is +3. and then in the y, there's a shift of 2, a shift of 2, a shift of 2, a shift of 2. So just reading the table, it looks like delta y is 2. So my slope is 2 over 3. Of course, to be sure, how about we pick a couple data points? There's my x1 and my y1, my x2 and my y2. And if I plug that into my fancy formula, right, we get 3 take away 1, 4 take away 1. There's my 2 over 3 yet again. All right, and of course, you could also invite you to visually plot the data. And if you plot it, you'll see that 3 and 2. Okay. Last but not least, we got another table, and something interesting is going on. You'll notice that there is no change in the x's, right? So my delta x is 0. There's no change whatsoever. Meanwhile, my y direction, we're going up by 1, right? Up by 1, up by 1, up by 1, up by 1. So delta y is 1. So when I try looking at my formula, right, delta y over change in x, we get 1 over 0. And of course, I hope you guys remember when we divide by 0, we are undefined. All right, it's not 0, it's not anything, it's undefined, it's just not doable. Graphing, I will graph this one. If we were to graph this, right, my x's are 2, and then we have a negative 3, a 2, negative 2, a 2, negative 1, a 2, 0, and a 2, 1. And so what we're looking at in this case is a vertical line. So vertical lines have undefined slopes, and I think you saw in an earlier video, horizontal lines have a slope equal to 0. And then of course lines that have a positive slope are on their way up, and lines with a negative slope are essentially on their way down. All right, so almost 3 different ways to calculate slope. The formula, visually counting it if you get a graph, or perhaps you actually just physically see the changes in the data as you go along. All right, so one more video to cut with regard to slope, and we're almost done.